in this circle here, we have two different angles. This red angle here is called our central angle because it's coming from the center of the circle. And if it measures 60 degrees, then the intercepted arc out here also measures 60 degrees. However, this purple angle here is what we call an inscribed angle. It has the same intercepted arc, but its measurement, as you can see, is not 60. So let's measure it and see what it is. So looking at this purple line here, it's going to be 30 degrees. So this purple angle here, this out of the way, is 30 degrees. So we can hypothesize that our intercepted inscribed angle is going to be half of the intercepted arc, which is the same as the central angle. So this is theorem 10.8, where it says if an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. Make sure you copy this down from page 613. Next up is theorem 10.9. 10.9 has two inscribed angles, but they have the same arc. So these yellow angles right here both have the same intercepted arc. So if two angles intersect the same arc, they create the same arc, then their measurements must be equal. So yellow, blue, yellow, these are all congruent angles, and they're all equal to 30 degrees. So this is theorem 10.9 that says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So be sure to copy this one down from page 614. Next up is theorem 10.10. So here we have a right triangle inscribed in a circle. So here's my right angle that's inscribed in a circle. So when that happens, this line here, our hypotenuse, is the diameter. Has to be the diameter because it has to be half, because based on our other theorem that says this inscribed angle is half of the intercepted arc, this has to be 180, which means this line has to be going halfway down the circle, which is the diameter. So theorem 10.10 says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So you know, if you have a diameter here, then this is an inscribed angle, and you could use trig if you needed to find any of those missing sides. Make sure you copy down this one from 615. And the last one is theorem 10.11. So here we have a quadrilateral inscribed in a circle, and it is inscribed in a circle if and only if the opposite angles are supplementary. So if you think about this is our inscribed angle here, and it's got the arc here. So if I make this angle, so if this inscribed angle is 65 degrees, it means its intercepted arc has to be 130 degrees. If that is 130 degrees, because it is double our inscribed angle, the major arc out here has to be 230 degrees because it has to add up to 360. If this major arc is 360, that means its inscribed angle is 115. 115 and 65 add up to 180. So your opposite angles in an inscribed quadrilateral have to add up to 180. They are supplementary. So theorem 10.11. The quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Be sure you have all theorems 10.8 through 10.11 in your notebook.